Now we will move on to the next topic of morphological image processing, that is called the morphological reconstruction by dilation and erosion. So far we have seen the operation of geodesic dilation and geodesic erosion, and what we will see next is an extension of geodesic dilation or geodesic erosion. Suppose that you are performing the geodesic dilation, and we will write the geodesic dilation with these notations, that is you are dilating the image or you are performing the geodesic dilation of an image F using a marker G. Suppose that you are doing it for k times, and then you can say that this process is actually a reconstruction by dilation of an image F using the mask G. Okay, so the only difference in morphological reconstruction by dilation is you are performing the geodesic dilation k times, then it will become the morphological reconstruction by dilation. Now the question is, what is k? So the point of k is you are performing the geodesic dilation of the image F by the mask G k times, and even if you perform the same operation for k plus 1 time, then both will be equal. Okay, so the point is you are performing the geodesic dilation operation over and over again until the operation converges. If you have done it for k times, and even if you do it for k plus 1 time, both the results are the same, that is the image is not growing at all. At that point you can stop the operation, then the result of that operation is called the morphological reconstruction by dilation. And as just the dual of this operation, you can also have the morphological reconstruction by erosion of the image F using the mask G, and which is same as you are performing the geodesic erosion of the image F by using the mask G and some structuring element for k times. Now what is the value of k? If you perform this operation k times, and if you perform this operation for k plus 1 times, and if both the result are the same, then you can stop at that point. Then you will take this k as the value of k in this equation. As I said, for the reconstruction by dilation, for the reconstruction by erosion, we are repeatedly doing the geodesic erosion process until a point where the image is not changing any further. That is, if you do the geodesic erosion for k times, and if you do the geodesic erosion for k plus 1 times, if both images are the same, then there is no growth. So at that point you can stop the process of the geodesic erosion. Then we will call that process as reconstruction by erosion. And we will see a typical example how the reconstruction by dilation is actually taking place. Okay, so here I have an original image F, and I have a structuring element B, and this is a 3x3 structuring element, and I have a mask here. As part of the reconstruction by dilation, you have to first perform the geodesic dilation, and you have to repeat it until a point where there is no change in the subsequent operations of the geodesic dilation. So this is the first image F, and this is the structuring element, and this is my mask. So first you take this marker, then you dilate it using this structuring element, so you will get this result. Then you perform the intersection of this result and the mask, so you will get this result. Okay, then upon this image you are again performing the dilation operation with this structuring element, so the result will be like this, and you perform the intersection of this image and the mask. So what will happen is whatever is common for this image and this mask will only existing in the output, so you will get only these 4 pixels that is in the output here. Now again, if you take this image, you dilate with this structuring element, the result will look like this. Then if you intersect this image with the mask, the result will be like this. So this is the result after we have dilated this image geodesically 3 times. Then again after that you dilate this image with this structuring element, then you will get this image. Then you intersect this image with the mask, you will get this one. So this is the result after 4th time you have applied the geodesic dilation. Then again you expand this image, or you dilate this image using this structuring element, so you will get a result of this kind. You intersect this image with this mask, you will get a result of this kind. So you can notice that when you take the dilation of this image with this structuring element, the image will grow, but at the moment you take the intersection with this mask, the mask, the result of that intersection will look like the shape of the mask. Okay, so that is the point where you are stopping the process of doing the geodesic dilation over and over again. So you can see that at the moment when the geodesic dilation is applied 5 times, your process has been converged. So in this case the value of k is 5. Okay, this number is not relevant. What you have to do is you have to stop when 2 consecutive applications of geodesic dilation does not make change in the final result. Okay, now we will see a typical example where geodesic dilation can be used for the reconstruction operation. Okay, so in the first image I have certain text. Here in the example I am taking a structuring element of this shape. The shape is actually, we have 51 rows and 1 column, so that is the kind of structuring element that we are taking. Now what we will do is we will take this image as my original image, then you perform the normal erosion operation with this structuring element. Okay, so what will happen is whichever component of this image or whichever letters of this image is equal to or taller than this particular structuring element will produce an output in the eroded result. That is the normal erosion operation. You have this image, in this image, if there is any letter which is equal or taller than this particular structuring element, will be preserved as a dot or as a pixel or several pixels. Then all other letters which is shorter than or which cannot confine a structuring element of this shape will be completely vanished. Now what we will do is you take this image and perform a dilation operation on this image using this structuring element, then you will get a result of this kind. Okay, then you take the intersection of this image with this image. Now what will happen is, what are the areas which are common for both first image and the second image will be preserved. Now if you reconstruct this image, or if you do the geodesic dilation by using this as the starting point F and this as the marker B, as the mask G, and if you do it repeatedly until the operation converges, then you will get an image of this kind. Now the peculiarity of this image is, this image contains only the letter which are taller in size. All the letters such as O or E are eliminated, but taller letters such as P, T, L and D, etc. are preserved in the final output. So this is one kind of application of the reconstruction. I hope it is clear. Thank you.